Greetings. My name is Jim Emmert, and my amateur radio call sign is WB0URW. I made this video to assist the beginning pico balloon enthusiast on how to very easily predict the flight path of an amateur radio pico satellite. Just follow the instructions and you should be fine. In order to calculate where your balloon is going to fly over the next 3 days, you will need to know exactly where your balloon is at this very moment. This information is easily obtained by opening up your web browser and doing a search on aprs.fi. This will bring up a search list which should include aprs.fi Google Maps. Open this, which will bring up the APRS map. In the upper right-hand corner and in the box labeled Track Call Sign, type in the balloon identification that you want to predict its flight. Remember that you can only get an accurate prediction for a balloon that has recently posted its data on the website. I try to do most of my predictions within an hour of the balloon going to sleep at night. When the balloon call sign is typed in, click on Search, just to the right of the box. Your balloon will appear on the map, and there are 3 pieces of information that you will need. First of all, on the balloon data bubble, you will need the balloon altitude in meters. Then, on the right-hand side of your screen, you will need the date and time, and also the latitude and longitude. Once you have this information, you can close this website and then bring up your search engine again. Type the following words into your search engine: NOAA balloon model, and then hit return. This should bring up a list that includes Ready Balloon Flight Forecasting Tools, and open this website. This page should appear on your screen with lots of options on the vertical column on the left side of your screen. Locate and open Balloon Flight Forecasting Tools. When this new page opens, at the bottom of the paragraph, you will find Continue to Run with High Split Balloon Trajectory Optimization. Select and open this website. Scroll down to the bottom of the page and select the line that indicates degrees, minutes, and seconds latitude. In the boxes to the right, fill in the latitude and longitude of the last position of your balloon. Be certain to notice that on the longitude, on whether it is east or west. This changes as the balloon crosses the prime meridian and changes back when it crosses the international date line. The latitude will only change when the balloon crosses the equator, which is rare to have this happen, but it does occasionally happen. When the latitude and longitude is filled in, go to the bottom of the page and click Next. This page lets you select how much data that you want to use to calculate your prediction, and we're not going to change anything on this page. So go to the bottom of and select Next. The top of this page lets you select having the prediction run either forwards or backwards. Select forward, and the next line is the current date and time. Please notice that the time is the time at the prime meridian, or what is referred to as universal time coordinate. This usually runs 5 or 6 hours ahead of Iowa time, depending on whether we are on standard time or daylight savings time. If you got your balloon information while it's still flying and still awake at the time that you open the APRS map, you will not need to change anything on the date and timeline. The total run time defaults to 48 hours, and the maximum the computer will calculate is 72 hours. You can put in any number above 72 hours, but you're only going to get 72 hours of prediction. The start latitude and longitude lines are pre-filled in from the information that you filled in on the very first page, so don't change anything in these boxes. Level 1 height is the altitude of your balloon in meters, and select the box to the right that indicates above sea level. The other box indicates above ground level, but the APRS software indicates above sea level. Level 2 and Level 3 should both be changed to 0. Splitting level should indicate 12. This will mark every 12 hours on the predicted balloon path when you get the final report. On the display options, leave the plot resolution at 96 and leave the zoom factor at 70. The plot projection should be changed to Mercator, which will produce a rectangular map, which is the easiest for most people to identify land masses. Vertical plot height, these units should be set to meters above ground level, or AGL. In the label interval, I usually set to 6 hours. This will place a mark every 6 hours on the predicted balloon path. Do not change anything below this. Go to the bottom of the page and click only once on the request trajectory. This will take a few seconds to calculate all the information, but when it's done, this page will appear. In the middle of the page, click on the .pdf box and your predicted flight path will present itself. In 3 days, it looks like this particular balloon would fly from Italy to China. The red line at the bottom of this map shows a graph of height above ground level, and it's interesting to see this change as the balloon flies over mountains. This particular illustration is fun to look at because it appears that we fly over Mount Everest. There you have it. This is an easy thing to do. I mean, this isn't rocket science. Oh, wait a minute. Yes, it is. This actually is rocket science. Congratulations. If you have any questions about predicting your balloon flight, email me at the following address and I'll do my best to answer your questions. Thank you.